It's a pleasure to have you on the call as well. Thanks to everyone else on the call. It's a pleasure to have you join my session. And for those of you who don't know me, my name is Jean-Joseph. I am a data, I would say an AI, but I spent about 12 years working as a database administrator. So therefore, I'd like to keep, uh, I would prefer say I'm a data and a database administrator guy, data engineer, right? But since I joined Microsoft, I mainly focus in the AI. So therefore, I yeah, I'm a little bit, you know, in between data and AI. So with that, and I'm based out of New Jersey, originally from Haiti. You can see there is a French or Creole accent. So with that in mind, if I did say something you didn't quietly get it, I'll be happy to repeat myself. Yes. And I'm the founder and the secondary organizer of Data Driven Community. This community have a weekly webinar and yearly summit, which is feature data driven. It's scheduled for this September 25th, where we have over 60 different speakers live with will be live with us. So if you haven't registered yet, feel free to do so. Yeah, by going out to the datadrivencommunity.com. So enough about me. The purpose of this presentation is to walk you through a real life scenario, okay? And then go over a little bit of the value of having a meta data-driven pipeline. As we will leverage Microsoft Fabric, I will spend 1 or 2 minutes or even 5 minutes to introduce Fabric. Then after that, we will mainly focus on the demo. So therefore, 80% of this presentation is demo. We're gonna start with level 1 and raise it all the way to level 400, right? So speaking of the data pipeline team, this is the question you're probably asking yourself, right? And as you probably knew, right, a data pipeline is a system for moving and processing data from various sources to a destination for analysis. It's crucial because it enables data ingestions, support real-time processing, improve data quality, right? It also increases efficiency and offers scalability. This is very essential, right? Especially it's the backbone of any data-driven organization, ensuring, I would say, smooth data flow and enabling effective data insight, right? You can think of a data pipeline as a logical grouping of activities, right? That's it. That can be implemented using either ELT or, for example, ETL or even hybrid approach, right? If we have to think of ETL, this is the traditional way, right? When we use to extract, transform, and load the data, right? But the transformation occur before that data push to the data warehouse. So this is often due to the limitation of the target. In terms of ELT, it is a more modern approach that leverages the computational power of modern data warehouses to perform transformation after the data has been loaded, right? Regarding the hybrid, right? A hybrid approach might be used when certain transformation need to occur before loading the data, and this is referred to what we call ETL, and others can occur after the data has been loaded, and this is what referred to what we call ELT. So this approach provides flexibility and can be tailored to specific need of your data infrastructure, right? So depending on the specific requirements and capabilities of your data infrastructure, you can choose the most suitable approach. But speaking of data pipelines, right? What would be the benefit of having a dynamic data pipeline? That could be the question you're asking yourself, right? Let's dive deeper into the technical aspect and importance of the benefit of dynamic data pipeline. The first thing we can think of is what we call flexibility, right? Dynamic data pipelines are designed to handle changes in data source, data format, and processing requirement without requiring significant rework. This is achieved through the use of flexible data model, adaptable ETL processes, and configuration pipeline component. And there's another thing we might need to think of is what we call scalability, right? But before we dive into scalability, let me give you one example why, or elaborate a little bit why flexibility is better, right? In terms of flexibility, this is kind of crucial in today's I would say fast pace, right? A data-driven world where data source are required, data source and requirement can change rapidly. Without this flexibility, changes would require time-consuming and costly pipeline for you to redesign or re-implement your data. So therefore, during the development stage, it is ideal to think of building a very flexible data pipeline. For scalability, a data pipeline can scale up or down based on the volume of the data, right? So this is typically achieved through the use of distributed computing resource and load balancing technique, right? And scalability ensure that the pipeline can handle large volume of data efficiently, making it suitable for big data applications. It also ensure that resources are used efficiently as the pipeline can scale up during the period of low. I would say can scale up and down depending on the workload. In terms of resiliency, right? Dynamic data pipeline are designed to recover from failure and continue processing. This is typically achieved through the use of fault-tolerant design principles and robust error handling mechanism. For example, if a node in a distributed uh, pipeline fail, right? The pipeline can reroute the data to other nodes to ensure that processing continue. Resilience is crucial for ensuring data integrity and consistency, as it ensures that the pipeline can recover from failure without losing data. In summary, the benefit of dynamic data pipeline with respect flexibility, scalability, and resilience are crucial for handling the challenges of modern data processing because they enable the pipeline to adapt to changes, handle large volume of data efficiently, and recover from failures, ensuring that the pipeline can deliver accurately and timely result in a wide range of scenarios. These benefits are not just nice to have features, but are essential for any organization that want to leverage its data effectively. But here's the thing, speaking of the data pipeline, we need to understand the key concepts of the key component of a data pipeline in the context of Microsoft Fabrics, right? If you are new to Microsoft Fabric, if Microsoft Fabric is a SaaS service that combine multiple services that already exist out there. So combining them change sometimes the behavior a little bit, but it's still the same. So with that, on my demo, I will use Microsoft Fabric, but technically I will be dealing with Data Factory. So if you're familiar with Data Factory, there is a link services, right? Link services in Microsoft Fabric, also known as connections. So they allow you to link your data store. The function similar to like a service in Azure Data Factory, but offer a more intuitive way to create and manage them. And if you use to data set, is that in Microsoft Fabric, the concepts of data set is not applicable. Instead, connections are used for connecting each data source and pulling data. That's it. In terms of activities, the data factory under Microsoft data under Microsoft Fabric does have also three kind of activities. And activities in Microsoft Fabric um, um, define the level of actions you can perform on your data, right? Microsoft Fabric can support three kind of activities in the context of data factory pipeline. We can think of what we call data movement, transformation, and control, right? For data movement, they allow you to move data, right, from different sources into a single data lake, right, or your data warehouse, or to any sink or destination you wish to have, right, where that data can be stored, analyzed, and visualized. In terms of transformation, regarding the type of activities, is that data transformation in Microsoft Fabric involve cleansing, prepping, and transforming data using a low-code interface. And Microsoft Fabric support over, I would say, 300 data and AI-based transformations. So regarding control activity, is that if you think of control activity, they allow you to control the behavior of your pipeline. If we think of if conditions, if we think of a loop, so those are such control activities that allow you to control your pipeline. Speaking of a pipeline, in Microsoft Fabric, we can consider this as a logical grouping of activities um, uh, that allow you to perform different kind of task. So in if you use to Microsoft if you use to Azure Data Factory, you're probably familiar with triggers, right? Under Microsoft Fabric, when you're designing your pipeline, it will be scheduled, right? So Microsoft Fabric can leverage schedule to automatically run your pipeline. Other things you might need to think of, because when you're designing your pipeline, there might be cases where two different data center has to be able to communicate. This is where we might need to think of integration one time. However, in Microsoft Fabric, there is no concepts of integration one time. The executions of the pipeline is managed internally, right? In case if you're wondering, is that Microsoft Fabric operates, right, with the Power BI environment, integrating technologies like Azure Data Factory, Azure Synapse Analytics, and Power BI into a unified products. So this allow data and business professional to unlock the potential of the data within a familiar interface. So therefore, Microsoft Fabric integrate with Power BI Gateway, which are crucial for connecting cloud services to on-premises data, either via on-premises data gateway or VNet data gateway, right? So on-premises data gateway, they act as a bridge, right? Providing quick and secure data transfer between on-premises data and several Microsoft Cloud services, including Power BI. They allow organization to keep database and other data source on their own data center or network, right? Yet securely use that data in cloud services. So, regarding VNet instead of on-premises data gateway is that the VNet data gateway, this allow import or direct query semantic model to connect to data service within an Azure virtual network without the need of on-premises data gateway. So in Power BI, VNet Data Gateway require a Power BI premium capacity license. I need to keep that in mind. And then they securely communicate with the data source and execute queries and transmit result back to the service. So speaking of Microsoft Fabric, Tim, what exactly is Microsoft Fabric? If I have to summarize, you can consider Fabric is an end-to-end a unified analytic platform designed for business and data professional. So, right? That's it. In here now, we know what is the data pipeline. So I'm going to change the gear. We're going to mainly focus on the demo that we need to do. Consider you're working for an organization. Okay, let's say the organization name is Contanso, right? And then they have a request that's sent to us. Okay, we are the one that will get the job done. As I used to work as a consultant, everything is normally start easy, right? So what they said here, they have one or two new customer who will provide the same data structured, but with different content. That's one. And then they just want to ensure that data is loaded quickly because it's a one-time thing. So you're probably wondering or laughing. Yeah, that's exactly true. That's how they get started. And then they said the issue is, which is what we normally dealing, and we don't know exactly the full expectation. But for now, we just want you to load that data. That's all we need. Okay, and they said all tables need to have the same schema structured. You know, if you're working for some of the financial consultant company or healthcare consultant company, we normally have a tenant. Anytime when a member subscribe as a new customer, we have to go and provision the same schema definition because they kind of use the same thing, right? So what we would do and make sure we isolate the ETL or ELT process or the hybrid solution that we want to use. To get this done, what we would normally do, team, as all files have the same structure but different content. So it sounds a little bit easy, which is true at the beginning, and then they want to make sure one customer data will not be loaded to another customer data. So we have to isolate this. What we would normally do is we would launch, give me 1 second. We will launch either Azure Data Factory or Synapse Pipeline or even other tools. But in here, I'm going to mainly focus on Fabrics. So the first thing we would focus on is they said one or two files. Consider when we go to our data lake or FTP, we realize there are two files. The first thing we will do is connecting those two files, right? So what we're going to do, we're going to define a source where the data is located. You can see everything is hard-coded here, right? It's just one. And in here is that if you pay close attention, we define another source. This is this time for bike helmet. If you go here, the source is different, which is bike belt, right? And the destination, we will have to define this. And then when you execute this, the data load. But the goal is to get the data where it is and load it into Microsoft Fabric data warehouse, okay, for them to start analyzing that data. Here's the thing, Tim. If you don't know how to get started, right, because we only have 1 hour, there's a tons of things I have to talk, and there's different ways we can add the copy activity. This is one of the way we can have it. And if you need a graphical assistant like a wizard, this is how you can get it. And the only thing you have to do is to define your connections. You click on new. You just have to go and define your connections, and that's it. So now, once this is done, you can see the destination is here a lake house, okay, and here you can see the destination also is a lake house. Perfect. We done, Tim. We are done, and we give it to business happy. But after business happy, they realize that now they get the full information from business. And that full information come up with a complex requirement. So before it was something simple, now it is complex. So let's go. They said now one customer may have multiple files, okay, and we have 4 new customers added. So if we have 4 new customers added, if you allow me to switch different windows, is that if I go back here, Tim, you can see I can keep on adding copy task. I can keep on adding copy task. Consider it's 4, it's just 6 copy tasks. What copy task? What happened now if they have 10, 20, 50, 100? How can we handle that such flexibility? If you remember the 3 main key concepts in designing data pipeline, right? So now here, what should we do now? Okay, that's one of the issue. And also, they want not only to load that data to a data warehouse instead of a lake house, but they require the data science teams to have a different set of data to perform all kind of data manipulations, right? And then also, and they need to track the execution times for each files, okay? By providing the number of rows processed, in a complex environment, they want to know the data we receive from our client, does it match the number of rows we load into productions? And then along, they want you to make sure if there is an error, let us know. And I want you to send that error message whenever that package failed, send it to a stakeholder, okay? And the internal IT for them to do the needful. So now the process is a little bit complex now, and then they want to archive it, right? So now there were one more thing they said is that even though we will receive multiple files for each customer, we may decide to not load that data, even though if the file is present or not, regardless. So with that, we cannot hard code everything. We have to come up with a way to create a framework for that client to be able, okay, to load that data. So this is where the flexibility, the maintainability, and the scalability comes in, okay? So if we have to think of a metadata, right? A metadata-driven team is a method of data processing where the metadata drive the processing of the data, right? And if you have to consider your data as a metadata driven, you must be able to have a control table and use a framework and use that to control what should be executed, what not should be executed. And the thing is, if you're looking at, we normally leverage, we have to be able to change our parameter value on the fly. So therefore, if it has all parameter value for things like names, server names, the database names, the file directory, and even objects that are involved in the pipeline, okay, um, uh, so you have to be able to query them or have a procedure that are used to extract and load the data, right? So this is what we are going to do now. We're going to implement. So in order to implement that, right? So we have to understand the stage of the development. So not only we want it to be meta data driven, but we must be able to, for example, develop that data pipeline in a way that is reusable, right? If we have to think, we have to think of modular design, right? So in a modular design, the data pipeline is broken down into smaller independent module, each performing, for example, a specific task. So this is akin to the principle of divide and conquer, because with that, we will be able to deactivate or reactivate a part of your pipeline, because by breaking down the pipeline into smaller parts, it becomes easier to understand, develop, test, and maintain. Each module can be developed and tested independently, reducing complexity and improving reliability. Moreover, module can be reused across different pipelines, promoting code reuse and reducing development time. Right. And then we also have to take in consideration to take advantage of what we call parameterizations, right? So parameterizations involve making your pipeline component configurable through parameters. This allows the same component to be reused with different configuration, enhancing flexibility and reusability. For example, if a data ingestion module could be parameterized to ingest data from different data sources, this approach reduces the need for duplicate code or activities and make your pipeline more adaptable to changes and requirements. And in the context of data pipeline, parameterize or parameterizations typically refer to the process of defining or configuring the behavior of a pipeline or its component, right? And then what should we think? We should think of standardizations, right? And standardizations involve using standard format, I would say data format and interfaces, right? So this ensure that pipeline component can work with different data sources and can be reused in different contexts. Standardizations reduce the risk of error and inconsistencies that can arise when dealing with multiple data formats and interfaces. It's also make it easier to integrate with other systems to reduce component across different pipeline. We can think of template pipeline, right? Template pipeline are predefined pipeline for common use cases. These can be used as a starting point for creating new pipeline, saving, I would say, saving time, right? And effort. For example, a template pipeline could be created or ingesting, sorry about that, ingesting data from a specific type of data source. Other developers can then use this template as a starting point, customizing it to meet their specific need. We normally have to think of what we call library and component. Maintaining a library of commonly used pipeline component allow these components to be reused across different pipelines. This promote code reuse, reduce development time, and ensure consistency across different pipeline. The library could include component for data ingestions, data transformation, data validation, and even the data output and more. Then documentation is the key, right? We cannot leave documentation behind because documentation involves providing clear and comprehensive information about how to use and reuse pipeline component. So good documentations make it easier for others to understand the purpose and functionality of each component, how to configure and use them, right? Each one, and how to integrate it into their own pipeline. So this is not only promote reuse, but also improve maintainability as it become easier for others to understand and modify your code. So with that in summary, right, best practice not only make your data pipeline more flexible, but also reusable in and maintaining, right? So if we have to go over the newest thing, how can we get it done? There's two ways we can get it done because there's two levels we need to maintain the error exceptions first of all. So let's go over the framework. This is a little bit simpler, okay, just for information. And if I go back here, you can see that in here, what I'm doing here, I'm creating a metadata because I do not want to keep on adding um, um, tasks, even though if I can handle this dynamically, and I must be able to create one data pipeline and set anytime when there is a new customer subscribe under that tenant, all we have to do is to register that tenant. And that's it. So with that, this is what I'm doing here. I'm creating a schema, call it metadata. Under that schema, I'm creating a table, called that table server. I have a server ID. I have, for example, a server name and the date it's created or registered date. So you are free to add the version, the OS, and everything. And so now I'm creating an application ID under that same schema, and I'm bringing a server ID because that application will tie to a server. Within that application, remember, the customer said they want to load the data or not to load the data, either if the data, regardless if the data present or not. So for that same reason, they may say, okay, now this application is decommissioned, we don't need them. So there must be a way for us to softly delete that in case if they need it later, all we have to do is to reactivate this. So this is what I'm doing here, right? So we need to know where those files are located for us to get those files and load them to our data warehouse. For each storage, we need to know what application information reside under that storage. That's why you see, for example, on the application ID, we have the name, the extension, and everything. And then after that, we have a table control. Because I remember sometimes the way we done this is that even though we have a source code, but anytime when our code has been modified, we go to our framework and update this, because once we register a member, okay, once that member has been registered, sometimes the name of that member is what we will use as a schema. It may not exist. So therefore, we need to have a create name from the application, there will be a drop down, give the customer name and everything. So that customer name will automatically become a schema. And depending on the volume of the data, we might break it down into a database as well. So this is the required table, configuration table for that customer, and then the metadata we need to insert, right, for that customer, and then we just have it a create date here. In here, these are, for example, a table that will hold down the all the information regarding each, for example, process. For each execution, we want to log the execution times and everything. As you can see, we have a start time here. We have an end time, even the date it is executed, and then we have the durations. So we're giving them every information. And for the error exception, we are bringing the process ID. How we're bringing the process ID is that for each executions, we're going to generate our own ID. So therefore, it's fair. We know we're sharing the latest information with that stakeholder, if you recall, or also with any internal IT support for them to quickly identify which execution failed for which business ID and what they have to do. So now that's the table. And here is that if I change here, you can see by creating those tables, I already populate the information. We have 1.7 name. We have one application, right? Under the application, we have n numbers of data. As you can see, we have data coming from all over the place, right? So we mark them. This is the application ID. And this is the file name, the extension, and then this is the container name where that file is located. And then this is the create the table control. Under that table control, we have create schema, create table, insert the metadata for that business. And then in here, this is where we control, for example, should we load a file? Take a look here. If I execute this, what this is giving me is that, how can I explain this? Is that you can see it's giving me the entire information that I need, right? The endpoint, the incoming directory or container, the destination where I have to archive, zip and archive that files, right? As you can see here, and it also gives me the schema name. That's going to be the schema, and it also gives me the script to create the schema, the script to create the table, and the process ID. If I go and read the definition of the store procedure, we will see that we point to only files that is active. So consider when we're receiving the files, we send them an email. Those are the number of files we have. Which one would you require to be executed now? So once they validate it and they reply, there will be an automated process, collect that information and perform the update as necessary to go to that file and disable the one that should not be executed. So therefore, we give them a way to control that. And then this is the way we control the logging process. If you see here, we create a store procedure that have all the required input parameter here, and then we insert those information here. So now this, if we execute this, you will see that those are the ones that we execute before. If we want to analyze the last executions, we can see it's give us the last executions, how long it takes and everything. That's the same thing we are about to do. Okay, in here is that they need to make sure if it's failed, they are on top of that. So this is the store procedure that log the error message, okay? And then this is the table where the data will be inserted. So as you can see, we keep track of the all error message. If I want to see the last error message, and you can see now, I can take a look and read. And I can send that information, which is the same thing we are about to do now. So now we have this one. We already create that database and in the schema to log that information. What we need to do is to come here. So therefore, we need to make this dynamic. Instead of having multiple, we can dynamically get that done. So what I'm doing here, I'm using what we call a kilocup. If you recall, on under my kilocup, I have a store procedure. That's the store procedure we just read that look for only file that is enabled. If I execute this, you will see that. Give me a second. You will see the same information we were seeing under that store procedure is the information that is here, right? So now what we are doing here, there is an array of value, like a table in memory. Let's put it this way. We need to pass that uh, to process each files. This is where the files are located. If I click here, you will see that those are the files. So we need a way to um, uh, connect to that data lake and then also load that data to Microsoft Fabric. So now to do that, we require a for each loop to iterate, right? And then that for each loop, if we click here, you can see we have to get that information dynamic. If you see that name here, it is the same name we have here. We just get the array output from this activity. So now we have access to the entire record we can look through to get that done. And in order to get that done, if you recall, what I'm using here is that I'm using inside of my follow, I'm checking to see if the file exists, right? Because if the file doesn't exist, I do not want my process to fail. I want to know if the file exists. That's what I'm doing. And the main goal is they want to prioritize the data for the data warehouse. If the data warehouse was able to execute successfully, then the process should continue. Otherwise, it should stop. You can see now the copy data into the lake house has to wait until the data, sorry, here. And this one has to wait. This one has to wait until this is completed. And in here, what I'm doing here, I'm creating a script. It is an expression and I get it. So what this one is doing is that I am getting, okay, the create schema from the output we got here. If you recall, when we execute this stop procedure, let me show you if you recall that. I think this is this one. You can see we have some create table schema. So this is exactly what this one is doing here. So we want to create the schema if it doesn't exist. In here, what I'm doing, I'm getting the start time. And then after I'm done, I am loading the data, okay, on copy. Here, I'm loading the data from my data lake into my data warehouse. And then in here, I'm doing it into my lake house. So what I'm doing here, I'm getting the end time because this is the most critical one. They don't care about this one, but if this is succeed, everything else should proceed. So with that, so what I'm doing here, I'm setting up some variables. That variables is what will insert that data into my database, right? Where I will log the execution times, the process ID, the app ID, and all information, the start and the end time, how many rows copy. That's how I formulate that expression. If you remember, if I go under my log, let me go back here, you will see these are the input parameter. So this is the row copied, right? Rows copied. If you go back here, you will see the last one is the same. So we are dynamically, okay, generated those informations right there. So we got the app ID. Where does the item come? It comes from here. You can see if I'm concatenating. Because I'm concatenating, that's the reason why this is not so much showing as activity, but if I go back here, I click here, you will see Give me a second. In here, I can type and call the instance or segment that I need from that. So we do not want this, okay? So what I'm doing here, if it's error out under this guy, okay, what we need to do now is to get that information and log it. So we are performing the same thing and we getting in here the error message. So where we focus is in this one. If you pay close attention, you will see this activity point to this activity. And what we want to retrieve from that is the error message. So with that, and then we create this, but we will need a way to execute that. And the best way to execute that is to take advantage of script task. In script task, what I'm doing, I'm calling that variable back from the expression, if you see here. And then for script task again, regarding the error batch. So what I'm doing here, if I click here, I'm calling the error, this variable that I just assigned here. That's what I'm doing. So now what I want you to understand, I already execute this if you see this, but it will take about 20 seconds to execute, okay? But it's if I go back here while I am explaining this, let me go back and execute. Hopefully I didn't change the anything. So if you see here, now it is executing. So what it's going to do, it's gonna grab the entire information from here, right? And then it will pass that into for each loop, and for each loop we'll get that information and loop through each file that is here and load those files into the data warehouse. So while this is executing, I'm going to stop here and ask if you have any questions, and I'll be happy to answer that for you. It might take another let me see, it might take another 30 seconds. Okay. In the meantime, if you have any questions, feel free to let me know. Can we get the source code? Yes, I will share that. I will share my GitHub with you. Definitely, yes. Also, so now you can see now, if you see here, we still have something in parallel. The reason why we're seeing this in parallel is that if you click here, we go on setting, we didn't check this. If you want to execute this in sequence, we could have done this. We mark this, and if this is in sequence, we done. We are done. So perfect. So now here's the thank team. So hopefully this is done. And while this is going on, what I'm going to do, I'm gonna change, okay, one file here. Give me a second. Let me do it this way instead. I'm gonna change this one, and if you see I'm going by column ID, I have index 1, index 2, index 3, index 4, index 5, which is order quantity. So I'm gonna force the data to fail because this is strict data type. We already define it. We're dealing with what we call RDBMS. So now by forcing this to fail, okay, let's see if this is finished. Okay, this is finished. So now what we can do now, we can go back here, team. We can access the last executions, okay, and see the progress of them. So now if we go back here, you can see now, you can see lucky for us, it's a small thing, each take the same times, but you can see the entire data load, right? As you can see here. Perfect. So now here's the thing. Now we just save this. We know this will fail. So what I want you to understand is that if I go back here, I re-execute this, right? And if while this is executing, where I want to go with you is that this is the last error. I tested. So you can see the time that I tested, and now it is uh 50. I tested on 13. So it's 50 now. So we're gonna see a different ID created. If you remember, the process ID is 5149. We generated a new process, but the way we can quickly see that is that if we execute this, we can see all kind of the last process that is executing here. So from there, we can tell what is, I think that was the last one. Yep, that was the new one. Yep, this is the new one. So now, as we save this, we should go back. Give me a second. We should see, and we have one failure now. That failure will be saved because we handle this. And I will show you you should not only handle if the directory exists, if the container exists, or if the data, but what happened if something changed at the root level. This is what I'm going to show you. Hopefully this is done. Probably wait for another 10 seconds. We should see this is done. Yep, this is done. Now, if we go back here, Tim, we can go back here. We execute this. We remember that this was the um, um, uh, process ID. Now we have a new one. We have 5 files. Let's see for the process ID, will we get 5? Now we can see we get 4. So the one that fell, we logged that and then we got that information. And then if you remember, let's go back here. If you remember when we create this, we get the error message. If I click here, okay, if I click here, it should tells me it is related to what we call data mismatch conversion, and it should also tell me the colon ID and the colon name. So now I have those informations, and now it's easy for the vendor that's sending me those data to quickly go and revisit. But here's the thing, we are not done yet. Let me show you something. Let me fix this error. And I want to show you, I'm going to save this. Instead, what I'm going to do, Tim, I'm going to go change I'm going to go change the name of this one. Let me copy this. And I want you to see what will happen. I'm going to change the name. By changing the name, let's add 4, just to force it fail. So now we know the name is changing. The way we design this doesn't fit for that. Okay? Doesn't fit for that. So what I'm going to do, I'm going to execute this, and I want you to notice that how the entire pipeline will fail, how it's going to be struggle. So therefore, whatever we have done works, but it is not working to the level that we wanted. So if you be patient with me while this is executing, I'm going to click here and explain what I'm doing here, okay? What I'm doing here now, I'm implementing or adding more logics, which will require a bit of time, but at least we handle our pipeline the way we're supposed to. So I'm going to get the metadata. So before this is executed, I want to make sure everything is in order, right? And I want to get the start pipeline here and the end pipeline here. But inside of my for each loop, I want you to notice there is one more component added. I'm checking again because the root might be renamed or the account might be renamed. But if there's any issue regarding to the child directory, this can fail as well. So that's what I'm handling here, right? In here, I am using a functions. If you go, sorry, if conditions. So if I click here, I can see if, give me a second, let me bring this up, okay? And let me bring this back a little bit. So if this is happen to be true, this is where I want this to, if the file exists, take place of that conditions. So if this one finish completed, it is true. So I want you to proceed, and that's it. But if this one fail, right, consider, for example, if any failure occur here, I want this to take place. And I want to send those emails. And for me to send that email, so if I open this first on the two, you can see this is the same logic we had before. If I go back one more level, give me a second, and I go back here and open this, you will see all I'm doing here, I'm setting up a, for example, a send mail activity. You will require to sign in to your Microsoft 365 thing, okay, email, make sure you give it access and everything. That's what I'm doing here, okay? And then, so therefore, if it's fail, let me go back to here. You will see how this guy is struggling. You will see error is all over the place. That's not the best way to do that. And to prevent that, what I can do, I can execute this now. As soon as it realized the directory is, for example, has been, the directory doesn't exist, what it's going to do is send an email. I want you to notice what will happen now. What it's going to do, check if the directory exists, and take a look once this is okay. So you can see get the metadata. So it's checking for each files. So when the check cannot be validated, it will realize something goes wrong. What it's going to do, it will go and send an email to the stakeholder as the business request, or along with the IT team, the team that must be informed. You can see now in less than 15 seconds, you should see that the email sent will take place. Take a look. This is the conditions now taking place. And I want you to see, and we have email sending for each files, as you can see. So our pipeline didn't go to so much strategy. So with that, we were able to please our customer. There's more things we can add, more logics, but it's just 1 hour presentations. But those are the things sometimes when you're designing a dynamic data pipeline, you need to take in consideration. So with that, I know I have 3 more minutes, even though I speak a little bit fast. Hopefully my accent was not um, too much a big deal, and I hope you get something out of this presentation. If you do have a question, feel free to ask.